So wherever there's a piecewise function and you have something that's discontinuity, if, for example, in this last one, if I said, what is the limit of f of x as x approaches one? Well, we have a problem. Because if I went to my calculator and I plugged in numbers just a little bit less than 1, like 0.999, it would get really close to the blue 1, 1. But if I plugged in numbers that were really close to 1 from the right-hand side, it would get really close to 3. So because there's this big jump in points at this point, and the limit from the left is not the same as the limit from the right, we would say that the limit of this function as x goes to 1 does not exist. Even though when x is equal to 1, we've got a point, which is 3. When you plug in 1, you get 3. It's not even a non-permissible value. But the limit does not exist because coming from the left or coming from the right, you run into different numbers. So the way to look at limits from the left and from the right, we put either a positive sign here or a negative sign. One negative here would be a left-hand limit, because we would do 0.99, something from the left that's close to 1. Now, as we're coming to f of x from the left, we would be looking at this equation. So this would be, sorry, I wrote my negative in the wrong spot there, 1 negative. So the limit as x approaches 1 from the left side of this would be x squared. And then you would just plug in 1, and 1 squared is 1. So the idea being, as you're coming from the left, you're on that parabola. And the value you're approaching when you come from the left is getting closer and closer to 1. Similarly, the right-hand limit, in this case, and you write that with a 1 with a plus of f of x, well, from that side it would be the 2x plus 1. And just plugging that in, the right-hand limit would be 3. And this is where we talked about before. If the right-hand limit and the left-hand limit are not the same, then that limit does not exist. And this is the mathematical way to write that out, which looks really complicated. Impresses friends at parties. Eh?